For section 1.2, we're going to take a look at inequalities. So the first thing we want to take a look at is, how can we tell if a number is a solution to an inequality? So our warm-up problem is this. Is -4 a solution to the inequality below? Well, if we want to know something works, all we're going to do is plug it in. So here we go. I'm going to do 5 times. Now, -4 plus 7. Right here, I'm doing -4 plus 7. That comes out to 3. Minus 3 times 1 minus 2 times the number. So 1 minus 2 times -4 is -8. So I have 1 minus -8. That's going to be a double negative, turns into a positive. Okay. Is that greater than 10 minus 3 times 3 minus -4? 3 minus -4 is 3 plus 4, which is 7 minus 1. All right, so let's see what happens here. I've got 5 times 3 is 15, minus 3 times 9 is greater than 10 minus 3 times 7 is 21, minus 1. Well, this is 15 minus 27. 15 minus 27 is -12, which is greater than 10 minus 21 is -11. -11 minus 1 is -12. So the question is this a true statement? Is -12 greater than -12? The answer is no, it is not. That means -4 is not a solution to this inequality. But let me ask you this. What if, I love the what if game, we're going to play it a lot this year. What if I change that to an equal to? If I change it to this, then the answer would be yes. But that's not what the problem said. I would have to change the original problem to have an equal to, make it a greater than or equal to make this a true statement. A number is never bigger than itself. A number is never smaller than itself. A number is only equal to itself. So to check if a number is a solution to an inequality, all we want to do is plug the number in and see if we get a true statement at the end. All right. So now let's take a look at solving some basic inequalities. We're going to solve and then graph them on a number line. Okay. So problem number 1. We want to get the b on one side and a number on the other side. So I'm going to do the distributive property here and here. So that's going to give me 3b minus 2b plus 10 is less than, distribute the 2 here, and I get 2b plus 8. All right. So this is really b plus 10 is less than 2b plus 8. All right. I'm going to subtract the b over, so I can keep the b positive, which means I'm going to eliminate this, and I'm also going to subtract the 8. So that's going to give me 2 is less than b, which is the same thing as saying b is greater than 2, okay? So b is greater than 2. Now, when it comes to drawing this on a number line, here's what I expect to see. All I need to see is the one number of interest. Our number of interest is a 2. Now, I need to pay careful attention to, is this an open circle or a closed circle? Are we including the 2 in our answer or not including it? We are not including the 2, so I'm going to put an open circle. B is greater than means go to the right. So that means all numbers 2 or greater than 2 would work. 2 itself does not work because there's no equal to here. All right, so that's my final answer. B is greater than 2, and then this number line is my final number line to correspond to b is greater than 2, all right? You could also draw your number line with the circle right on the line and then draw from there as well. I see that a lot. Sometimes if you draw your circle little, it's hard to tell if it's open or closed, so a lot of times you'll see me draw it above the number line. Okay, problem number 2. Let's see, I want to get rid of the fraction. So what I'm going to do is I'm going to multiply both sides by the reciprocal, -5/2. A number times its reciprocal should give me 1. So on the left-hand side, I'm going to have a p. But I multiplied by a negative. Now, anytime you multiply or divide an inequality by a negative, you need to flip the direction of the symbol around, okay? Now I have to do 10 times -5 is -50. -50 over 2 is -25. Okay. Now I could have done that in steps if I wanted. Okay. if I go back to the original, negative 2 over 5p is greater than or equal to 10. My alternative work is this. I could have done, okay, times 5 times 5. And that would have given me negative 2p is greater than or equal to 50. I didn't turn the symbol around because I didn't multiply out the negative yet. And now my next step would be to divide out negative 2, divide out negative 2. And that's when the symbol would flip around to be a less than or equal to, and I still get negative 25. So now how do I put this on a number line? I only need to mark the number of interest. The number of interest here is a negative 25. This time I have an equal to, so I do a closed circle. And I have p is less than or equal to negative 25. So I'm going less than is to the left. Okay, so this is my final answer set over here. All right, so there's number 1 and number 2. We're going to go through 2 more examples in this video. Okay, so problem number 3 and problem number 4. Problem number 3 has fractions involved, so I'm going to start by getting rid of the fractions, which we talked about in section 1.1. So we're going to go through and multiply by the least common denominator. So here, my least common denominator, keep in mind that this is over 1. Let's see. 1, 2, and 5 is going to give me LCD of 10. So I'm going to multiply the whole thing by 10 over 1. Okay, so that's going to give me 10 times x minus 4 divided by 2 plus 10 over 1 is greater than, let's see, 3x times 10 is 30x over 5. Well, the 10 over 2 right here, the 10 over 2 over there is really just a 5. So this is 5 times x minus 4 plus 10 is greater than, let's see, 30 over 5 is 6. I'm going to distribute now the 5 to get 5x minus 20 plus 10 is greater than 6x. I'm going to subtract over the 5x and then combine like terms. So negative 20 plus 10 is negative 10. Subtract over 5x to get 1x. So I get x is less than negative 10. X is less than negative 10. So x is the smaller thing, negative 10. Okay. Putting that on a number line, again, just mark the number of interest. The number of interest here is negative 10. I am not equal to, and I'm going to be less than. Less than is to the left. Okay, so I want this number line as part of my answer, and then this is my answer. Either one is fine, really, but I'm going to go with the one that has x first. Right? One more example for this video before we talk about compound inequalities in the next video. So same idea, I'm going to multiply through by the LCD. Looking at the denominators, I've got a 2, a 6, and a 2, so my common denominator is the 6. So I'm going to take this whole thing, I'm going to multiply it by 6 over 1. Okay. Now, I'm going to say, just in the interest of space, all right, 6 times this fraction. Well, 6 divided by 2 is 3, so that's going to be 3 times 3a plus 4 is less than or equal to. All right. Now, when I do 6 times this fraction, the 6 and the 6 will cancel off, okay? So that's actually going to just give me the numerator, okay? And then I'm going to have, one last time, the 6 times 5 over 2, whoops. 6 times 5 is 30. 30 divided by 2 is 15. Okay? All right. If you have any questions on how to clear out these fractions, please make sure you reach out and let me know. I'm happy to go over it with anyone that needs a little bit more guidance on that. All right. Distributive property on the left is going to give me 9a plus 12 is less than or equal to. Distributive property on the right, 9a minus 3 plus 15. So I'm going to get 9a plus 12 is less than or equal to 9a plus 12. Huh. What does that really mean? All right, well, that's the same as if I eliminate the a's, 12 is less than or equal to 12. Well, that's a true statement. So what does that mean? That means my solution is all real numbers. means any number that I want to plug in for A is going to work in this inequality because the two sides are actually equal to each other. So the left side is always less than or equal to the right side. So then how do I draw a number line for all real numbers? Well, you can mark any number that you want. I tend to mark as 0 because 0 is the center of a number line normally. So all real numbers, everything goes. I draw an arrow going both ways because everything is included. All right, we'll talk more about all real numbers when we review this stuff in class together. All right, so this is my number line, and this is my actual solution, all real numbers. All right, so that is single variable inequalities. Next up are compound inequalities. See you there.